Yeah, so 27 is 3 cubed, which means I can split it into 3 squared and 3 power 1. This goes out, and that gives me 2 times 3 square root. This stays in, so that's 3. So that is 6 square root 3. That's the simplest case. What was the next one?
So yeah, I just got confused with the squaring part. I thought I had to square the 6 for a second, but लेकिन मेरा ठीक आया. So number 8.
Number 8. Okay, square root 200. We did it in class yesterday. So this I can write as 2 times 100. And I already know what 100 is. It is square root of 10. So I can just put 10 outside and the 2 in.
Okay.
Okay. Yeah. What's next?
And 13.
13. Okay. 2 square root 2 equals to square root 4x. Now there are two ways of doing this. One way is that you take square on both sides. So when you square both sides, you get 4 times 2 equals to 4x. This 4 cancels with this and x equals to 2. Okay, that's one way. The other way is that, remember I told you that if you can take something out, just like I've taken this out, you can also bring things back in. So when this goes back in, this becomes, what is 2 squared? It is 4, right? So this becomes 4 times 2. And that's equal to 4x. And you can clearly see that this 4 is this 4. So x equals to 2.
Okay.
Yeah.
Yeah, okay, I got it right. Yeah.
And
1 second. So abhi 16.
16. Okay, hold on.
That's the last one.
So 4 square root 3x equals to 2 square root 6. Okay. So basically what this is telling me is that, first of all, simplify this. So this 2 and this 2, they simplify, you get this. Okay. Now this means that I can move this inside. So that makes it 4 times 3x equals to square root of 6. The square root cancels out. So 12x equals to 6, so x equals to half. Okay.
Oh yeah. Gee, I got the same thing. Yeah. Sorry.
That's okay. No problem. All right. So today we'll deal with percentages. Okay. Now there are two things that you need to know about percentage. Number one, percentage is, I don't know the correct word for this, but you can reverse them. For example, if I say, what is 8% of 25?
Then you can go to 25% of 8. Yeah.
Yeah. So this is equal to 25% of 8. Now, one of them is much easier to solve because 25% is a quarter. A quarter of 8 is 2. Okay. So both of them are the same thing. They're 2. So that is first thing you need to know. All right. I'm going to solve a few examples. And from these examples, you will obviously build all the concept of percentages that we need to know for this. For example, this is the first example. I'm using this book, which is really good. Okay, so it says Jacob got 50% of the questions correct on a 30 question test and 90% on a 50 question test. What percent of all the questions did he got right? So here's the thing. Remember, the percentages don't add up as values add up. You can't just say, okay, 90 plus 50, that's 140%. Of course you can't, because that's more than 100. But even if it was 5% and 10%, don't add them up. You have to, whenever you calculate percentage, you have to calculate it for the total. Okay. So for example, in this one, the total for first test is 30. So it's 50% of 30. And this one is 90% of 50. But the final answer will not be 50% of 30 or something like that. It will be whatever percent of 80, because that's the total.
55%.
So I'm sorry, what's your answer? 55%.
75, 3 over 4.
75. Yes, that would be right. So here's what we do. Now, of means multiply, okay? So 50% of 30 simply means 50 of 30. And what is 50%? It is half, right? Half of 30, that's 50. Similarly, 90% of 50. So again, that is the same as 50% of 90, right? So I can just switch these numbers around. And that gives me a much better answer. That is 50% of 30 and 50% of 90. So that means this is 45. So the total he got right is 15 plus 45, which is 60. 60 compared to the total marks, 80. And my new percentage is 3/4, which is 75%. So there are a few percentages that you need to remember. For example, you need to know what half means, what a quarter means, what 3/4 means. And this is 50%, this is 25%, and this is 75%. Similarly, 1/3 and 2/3. This is 33%, and that is 67% or 66.66%. Okay, so those are some percentages that we usually work with. Similarly, 1/5 is 20%. So if it is 2/5, it is 2 times 20, that's 40%. 3/5, 60%. 4/5, 80%. Okay, so it's important that you know this, these numbers. Okay, here's another question. If you want to get a copy of this book is Panda Math or Panda Sat something. Okay, a record of driving violations by type and vehicle is shown. All right. Now, this is a question in which you have to read the table, and you don't read all the table, you read the relevant bits only. So the first question says that which of the following is closest to percent of recorded parking violations that were committed by trucks? Now, here's the thing. They're just asking us about trucks, right? So just this portion, the trucks. So what is that? In the table,
10.5. So see.
so the total for trucks is only for parking, okay? So parking violations. So I'm just concerned with parking and just concerned with trucks. So where do both of them match? Over here, right? So I'm going to just focus on this number for this thing. Parking violations by trucks. So based on that, I can say it is 17 over 43.
39.5, so 40%.
So that's 40%. Okay. Now here's the thing. If you're doing it on calculator, unless you have graphical calculator, the calculator with a percent button in it, you don't have to multiply it by 100%. For example, if I do this in calculator, I'll get 0.395. You got 39.5. So I'll get this. So just assume this is 39%. That's it. You don't have to multiply by 100 because the rest one moves. I think you know what that means. Similarly, the second one is if the data were used to estimate driving violations. So this is driving violation information. About 2,000 total violations in a certain state, which of the following is the best estimated number of speeding violations by cars? So again, go back to the table. Speeding violations by cars. So speeding violations are these. By cars, they're these. Okay. So, no, wait a minute. It's not. They're talking about the total driving violations. Okay. So speeding violations by cars is this, and the total violations is 284. So it'll be 83 over 284 times, what's the total now? 2000. So it's times 2000. Why am I doing this? Remember this thing. Whenever you have a new situation, the old percent is equal to the new percent, whatever the percentages are, if you want to apply them, if they're using the same proportion. Okay, so old percentage is same as the new percentage. Now, what's the old percentage? It is speeding violation by car divided by the total equals to new speeding violations by car divided by the new total. And new total is 2000. So based on that, I can just multiply it and get my answer. All right. So this is called scaling. You can scale a percentage. All right. Does that make sense?
Yeah.
Okay. The third kind of question that usually comes is when you have repeated percentages. So how do you deal with repeated percentages? So for that, remember that you always have to follow the pattern. Now, before we do this example, what you need to know is that in fractions, you have 100%, but that is also 1 in decimals. 100% is 100 divided by 100, that is 1. 80% is 0.8. So that means 80% can also be said as 20% less than, right? 20% less, that means it's 1 minus 0.2. Get it? 20% is 0.2. So for example, if I say the rate is 20% more, it's going to be 1 plus 0.2, 1.2. So your original is always 1. And whenever something changes to that, you add it to 1 or you subtract it from 1. So for example, if you're buying something and you're getting a 15% discount. Now, the usual method that we study in maths classes that first find the discount and then subtract it. So that would look something like this. So for example, something is for 2,000 rupees. Then if you get a 15% discount, then what you'll do is you'll do 2,000 times 15%. That will give you your discount, which is 300. Then you'll subtract 300 from 2,000 to get 1,700 as your final answer. Now you have calculators, right? So you don't need to do that. Just remember that a 15% discount means that you're left with not 100%, but 85%. So you have to pay just 85%. So that is 2,000 times 85%. That's it. That is your final price. Of course, that's not telling you what the discount is, but who cares? We don't need to know the discount. Okay, so that is something that we can work with, that you start and end with 1, and that's how you can easily change or scale percentages. So let's deal with this question. The price of a dress, okay, I don't know what that is. Let me just call it P, is increased by 20. So whenever you're increasing, you're adding, right? So if its original price was 100%, now the price is, what is it?
120%,
which is 1.2. So now it is 1.2. Okay. Then decreased by 40. Now the decrease is not on P, not on the original price. Decrease is on the new price, which is this thing, 1.2p. So now I'll say this is my 100%. And if I get 40% less, that is 60%, right? So this is going to be 0.6. Okay, this is my new price. And then it is increased by 25%. Again, that is 125%, which is on the new thing. So it's times 1.25. Okay, so what's my final price? My final price is going to be 1.2 times 0.6 times 1.25. I'm getting 0.9. So I'm getting 0.9p. So what does that, what does that mean? It means that 0.9 of the original percent price that I have. I don't know what happened here. Yeah, so 0.9 of the original. That means it is 90% of the original price. So what's my overall decrease? 10%. That's not what they've asked us in the question though. They've only asked us to find out. Okay, so it is 0.9 of the original one, which is 90%. Just give me a minute. Fixing my pen. Sorry. I don't know what happened. I'll restart this thing, okay? Yeah, so it's working again. Yeah, so here's the thing. So my final answer was 0.9p, which means it is 90% of the original price, which is what? Which is 10% less than the original price. So if they ask, they're asking what is the percent of original price? 90%. If they ask what's the discount? 10%. Okay. All right. So here's the thing. You're going to solve SAT, right? You don't have time to find out prices at every step. They've changed it like 3 times. Don't calculate your answers midway. Just go till the end. But of course, you need to have the confidence that what you're doing is you're doing it right. Okay? So that's important. All right. Here's another question. So that's the main idea of percentages. Any questions about percentages? So the main ideas you need to know about percentages. Number one, percentages are transferable. 8% of 25 and 25% of 8. That example. Second, that you can't add percentages. If you want to add percentage, you actually have to recalculate the whole thing. Then, whenever you have a table like this, you have to pick the relevant points. So for example, in the first option, they asked us for parking violations by trucks. So we just picked the parking by trucks and we were just concerned with parking. In the next one, they asked us for the speeding violations by cars compared to the total violations, which is why we picked the total and the speeding violation by car. So it's important to read the question and try to understand what the question's requirements are. And lastly, we said that whenever you're changing, whenever you're increasing or decreasing values, the change in the number is similar to the change in percent. But it's easier to keep track of percent because an increase is going to add to 1 and decrease is going to subtract from 1. Okay, so that is how we get this. So that's percentage. I'm going to give you a couple of questions for percentages and solve them. Tell me if you understand. Okay, we'll take this now.
So your screen is frozen. Nothing's changed.
Oh, wait a minute. Do you see it?
I only have example 3 still.
Oh God, what's happening here?
Same, sir.
I'll reshare. I thought you were solving the question.
No, I thought you had technical difficulties. So I was waiting.
Sorry about that. Do you see it now?
Yes.
Okay, go on, solve it. Yeah.
Yes, sir.
Okay. What about you, Moise, Irving?
Sir, मैं तो question पढ़ रहा था.
Okay, I'll give you another minute.
Sorry.
Oh.
Sir, can I see the answer?
Yeah, sure. What's the answer?
I think it's week 3.
I agree, sir.
Okay. So, how did you do it?
Sir, I did 38 by 1 divide by 167 first. It came as the wrong answer. 42 divided by 167 नहीं आया. फिर उसके बाद 53 divided by 167 into 100, it gave around 30%ish. So I just assumed that it's
Okay. What was your method?
Yeah, sir. I pretty much did the same thing. I took the averages of all of them, and I got 31.7 something. So I rounded it up to 32.
Do you think we could do better?
Possibly, yeah.
Because
दो हो गया, और क्या करना है?
percentages are transferable. What does that mean? That means I can say, instead of finding 38 over 167, is it 32? Why don't I say 32% of 167? And I
Yeah.
pick the answer that's closest.
Yeah, that's so slow. Honestly, I didn't even realize that.
Right?
Yeah.
So you can do it right away based on that. All right. Here's the next question that is relevant to this.
So for this, I just put 103 over 386, the totals.
Yeah, that's fine, because we have to find the all units for week 2. So yeah, whatever the answer is for that. Okay. Here's the next question for the same data. What is that? Are you getting a text or something?
Sorry, no, that's my computer. I'm using Spotlight.
Oh, okay. Yeah, so that's fine. Are you done?
Yeah, so it's
Yeah.
What's your answer?
D, 55.3.
55.3. Okay. How did you do it?
I put 47 over 85, the totals for week 1.
Yeah, that's fine. That's the method. Okay. So that was 1 for percent. And now we move on to the second portion of percentage. So far you understand everything, right?
Yes, sir.
Okay. There are basically 3 parts of percentages. The second idea is growth, or like how do values change if you add or subtract based on percentages. For example, if there's a percentage growth, first of all, that means things are changing in a ratio. Okay, that's the first thing. Secondly, there's 2 kinds of growth. There is one that is simple, and the second one is, you can see the screen, right? Yeah. So one is simple and one is compound. Now, both of them are based on some rate, some percentage rate. And the original price, people usually call it principal, because usually this is applied to interest calculations or profit calculations in the banks and all that. So principal, or the original amount, that's what you have. One is supposed to be your original amount, 100% of the original amount. That's where you start. Plus the rate, and rate is in percentage. And this thing is telling me how my rate changes with time. But which time? Time is going to be over here. So if I do this basically changes to P plus PRT. Okay, and what is that? That is telling me the total future value, or the total amount I'll get at the end of whatever period. So for example, if I invest $100 at a rate of 5%, then for 2 years, then it's going to be 100 as my original price, 5% as my rate, and 2 years as my time. So if I want to calculate it, my original is 100, and the change is going to be 100 times 5 over 100 times 2. All right, so that is 10. So this is my interest. All right, the interest that I get. And this is simple interest. Now, compound interest basically deals with you are doing what we were doing over here. This one, whenever the values were changing, like
Sir,
1.2. Yeah.
simple interest just PRT over 100.
Again, PRT over 100 is just the interest, and what you're doing over there is the over 100 means that you're not putting rate as percentage. Okay, you're just putting rate as 5, and that will work, sure. But in SAT, many questions are about the total amount, so you have to add P to that.
Okay.
And there's a reason I showed the formula like this. It will be cleared in just 2 minutes. The compound interest is basically that you calculate the interest once, then you calculate the interest again, then you calculate the interest again, just like we were doing that. The original amount times 1.2 times 0.8 times 1.25. What was I doing? I was calculating the change every time. That is compounding. So that's the same thing over here. So what am I doing? I'm going to multiply it with itself that many times. So instead of doing all of that and writing it so many times, all I can do is I can simply write principal times 1 plus r t times. So if you look at it, the formulas there's a stark similarity between the two formulas. But the only difference is that in one of them, t is inside and the other one, t is outside. So just remember that. In compound interest, t is in the power, and in the simple interest, t is inside. Okay. So if you know that, it's gonna do that simply. All right. Pretty easy. Now here's the thing. What's happening here is that t is in years, time is always in years, and rate is always based on the yearly model. Okay. Now, of course, there is sometimes that you don't compound the interest or calculate the interest at the end of the year. So what happens is that the rate changes according to that. So now the compound interest formula is going to get a little bit more complicated. So I'll just show you what that is. Now, if I don't do it annually, then that's fine. That's perfectly fine. But my value should be annual. So my total comes out to be, let's suppose I calculate my interest not annually, but I calculate it semi-annually. That means I calculate it 2 times in a year, or after 6 months. That's again 2 times in a year. So here's what I do. How many times do I calculate it? I divide it by that. And how many times in a year I do that? I multiply this by that. So one you have to divide, one you have to multiply. So in semi-annually, this is going to be 2. So for example, I invest $100 at a rate of 5% for a year. Then that would be 100 times 1 plus 5% for a year. If I do it for 3 years, this time is going to be 3. Now, here's what I'm going to do. What if I calculate it every month? So now, what is my rate per month? It's going to be this rate divided by 12, which is the same as saying you divide 5%, which is 0.05, by 12. You're going to calculate it 12 times in a year. So your rate, so if the rate was 5% for the year, for a month, it's going to be 5% over 12. But how many times are you going to calculate it in 3 years? 3 times 12, 36 times. Okay. So that is the difference we get. Now, this wasn't in O levels, I know, but this is the difference we get. And this is what we need to learn about whenever we are doing something multiple times in a year. Now, sometimes they say we do it per day, in which case you'll calculate it 365 times. Sometimes they say we do it per month. Sometimes it's per quarter, in which you're doing it 4 times in a year. Now, continuously is one special case which is not tested in SAT. But if you're studying calculus or financial maths over there, you might be interested in knowing that. But that is for some other debate. For today, just remember that the N is basically how many times you're doing it in a year. Okay, so that's the idea of growth. Of course, growth doesn't always come. You can also have some decrease, some loss. So in that case, your rate is just negative. So if somebody's getting a loss of 5% every year and it is compounded, then it's going to be minus 0.05. That's the rate. Okay, that's it. So that's the only difference here. So let's try a question. Yeah, let's try. So go on and do it. It's a pretty straightforward question.
There's a D.
Wait a minute. Jonas is 3% interest annually. Our initial about 1,000 was. So we are looking for the total. This is compounded, so it's 1.03 power 10. Yeah, that's right. Did you get the same answer, Maurice and Ibrahim?
Sir, can you explain this one?
So basically, the important numbers are we have 3% interest. Sorry, that's a rate. Annually, that's 1 time a year. Initial is $1,000 and the time is 10 years. So it's 1,000. It's compounded, right? So it is P into 1 plus R power T. So it's 1 plus R is 0.03 because 3%. Power time, that is 10. So 100 into 1,000 into 1.03 power 10. Do you get it?
Yes, sir.
Okay. Now, if you get that, try solving this.
Sir, oh wait 1 second. Sir, the answer is D.
Let's see. So what have you also done it? Both of you?
No, sir. I didn't even realize. I think I disconnected for a second.
Okay. Go on, do it.
So since it's semi-annually, will it be D again?
Semi-annually. So it will be two times a year, right?
I think so, sir.
Okay. So what's your answer?
I guess it's D.
All right. Let's see. So we are doing it 2 times a year. All right. So the rate is going to be divided by 2 now. So my initial deposit is 400. 1 plus my rate was 5, but when I do it 2 times a year, that is going to be 0.05 over 2. And I'm going to do it 2 times a year, so 2 times T. So there you go, 1.025. That's my rate. And yeah, it is D.
All right, sir.
All right. So that was growth. And yeah. Let me give you.
So when did you take the SAT?
Oh, 10 years ago.
10 years ago when it was out of 2400.
Yeah, it was out of 2400, but I canceled my score. I didn't need it.
You didn't need it?
Yeah, because I thought I needed it for LUMS, but then LUMS told me it was optional after I had given the test. So I just called them and I asked College Board to cancel it.
Why didn't you just find out, sir? Like, wouldn't you want to find out what your score is?
Because I was on the edge, to be honest. I was like, I don't know. And if I had done bad, that would have been really, really disappointing. So I just canceled it.
तो सर आपने स्कोर भी नहीं देखा?
स्कोर नहीं देखा, पैसे भी वापस ले लिए ना. That was another factor. पैसे मैंने घर नहीं दिए. Okay. Here's another question. Now this question is about when you're comparing two things, and I told you that new value and the old value, they're equal to the percentage that you get. So try solving this question.
So I think I know the answer. So I'll message you privately so that the others can do it as well.
You can just chat it here, yeah. Put it in the chat.
Is it correct?
Let me see. Yep. That's correct.
I'm not gonna lie, sir, I kind of did it mentally. I didn't need to solve it.
That's good. That's good. So what's your answer, Ibrahim?
Sir, 4,550.
4,550, no?
Achha, ek second. Sir, is it 5,950?
No, it's not.
Sir, ye kya baat hui?
Okay. What's your answer, Kaji?
He's not here, sir.
He left? Okay. So how did you do it, Ibrahim?
I kind of just did it mentally. I just thought, okay, to start off, I did 0.7 times 5,000 and I got it.
Oh, wait a minute, what?
Sir, I did it mentally. As soon as I read this, I realized 0.7 times 5,000 is 3,500.
Oh, you did it like that. Okay, that makes sense. That makes sense. And basically what you're thinking right now, if I were to elaborate on that, is that you have thought that the new value, this year's price is not, is 70% of last year's price.
Yeah.
That's what you've thought about. Okay. So, and that's important because in this question, what's confusing is that, wait a minute, if this is 30% less than last year, that means previous year's was something more than that. And then you calculate it like this. Most people, here's what they'll do. They'll say, okay, 3,500 has 30% less than the last year. So they try to figure out. One common mistake is you're like, last year was 30% more. So then you do this.
1.3, yeah.
But that's wrong, because last year wasn't a percentage of this year. This year is a percentage of last year. Okay? So that's important to remember. So this year, 3,500 is 70% of last year. So that means if you make an equation out of it, this is 70, 0.7 of last year. There you go. Okay. So, and of course, if you remember that what's 3,500, 70% off, of course that helps. All right.
Otherwise, how would you solve this, Serif? Like, if it was a random number, if it was like 5,011 something.
Here's what I do. My new value over old value is my percentage.
Yeah.
Yeah, that's how I do it. 3,500 over x is equal to 70%. And that's the same thing.
Sorry, I didn't get this at all.
No, sir. I want to know how you find the value 5,000 if you didn't do it mentally. Because I did it mentally. I don't know how to do it without using my brain like that.
Oh, if I didn't do it mentally, then here's what I would do. I would do 3,500 over 0.7.
Okay.
So this 7 goes, and that gives me 500. And this is 0.1, so the 0 comes here. So 5,000.
Okay. Yeah, I got it, sir.
Okay. Ibrahim, Moiz,
Ji, sir.
you have to translate this. They said 30% less than last year is 70% of last year. That's what you have to translate this to.
Yeah, I did that.
Yeah, if you're able to do that, then you know that 3,500 is the 70% of last year. So 3,500 is 0.7x, and then you just solve it. So that's the second idea of what percentage is to. And yeah, that's it. That is the percentage. Of course, there are some examples that we will solve in the next class where you have percentage change. That's the third thing of percentage. Then when things change, and for that, just remember that the percentage change is equal to, so percentage change over 100 is equal to your change, whatever the value changed with. So value change over original value. So that doesn't really make any sense. So let me try to explain. Let's suppose something was, so price of something was $50 and now the price is $30. What's the change in percentage? So you know that my change is not 30. My change is $20 compared to my original, which was 50. Two common mistakes that students can do here. The question was the price changed from $50 to $30. So number one, they can say that they will put 30 here. That's not the case, because the change comes over here. And second, they might put 30 here. But remember, 30 isn't the original price. 30 is the new price. So that is why the percentage change is always on the original price. So the percentage change, percentage over 100, is same as the change over original price. So 20 over 50. And if you do that, you know that this has decreased by 40%. Okay. So that's the percentage change that we get. And that is what the last thing is. How do things change in percent? For example, let's do two questions. You have time, right? I think my student is a little late today. The other one.
So what do you teach after this?
I teach A-levels chemistry after this. Okay. What did you get?
D. 46.92.
Yeah, that's right. That is right.
So yeah, I'm not getting the right answer, but I think what I did is that I did 470 minus 320 divided by 470 into 100.
So I did something similar, but I did 470 minus 320. I got 150, and then I divided that by the original 320.
So what you did is you found the change first, right?
Yeah.
Yeah. So always do that. Go for the change and then divide it by the original value.
That's what I did, sir.
Yeah,
So, sir,
that's right.
oh, the original is 320. Sorry.
Yeah. So you have to find the original one. Okay.
Yeah. वो मेरा भी D आ गया, sir. G46. I got 46.87. Yeah.
Okay. That's it for today.